Hello everyone, I'm Neelima. In this video, I would like to walk you through a data mining exercise using SAS Enterprise Miner tool. Let's look at the dataset first. This is our dataset, and in our analysis, we are trying to predict the class attribute. That is, we are going to predict the number of Republicans and Democrats in our dataset. Let's move forward with the SAS Enterprise Miner tool. Because the SAS Enterprise Miner is hosted on cloud, running all these nodes takes a lot of time. Due to time constraints, I have already run these nodes. Let's look at each and every node one by one. The first node is the file import node, and with the help, these are the properties of file import node, and with the help of import file option, I have imported the vote dataset, and with the help of edit variables option, we can edit the variables. Because we are trying to predict the class attribute, I have changed its role from input to target, and I'm keeping all the attributes. I'm not dropping any of these attributes. Let's move forward. The next node is the stat explore node, and this node gives us interesting statistical analysis of our dataset. That is, it gives the mean, median, mode, standard deviation, and etc. And the next node is the data partition node. This node helps us in setting the percentages for training, validation, and test datasets. There is no hard and fast rule as such, but it's always a good practice to give higher percentage for the training dataset. So I have given 60% for the training dataset, 25 for the validation, and the rest 15% for the test dataset. The next node is the control point node. This node helps us in building multiple models at a time. So I have built the decision tree model and neural network model. Let's look at the decision tree model results. These are the results of a decision tree model. This is a cumulative lift curve, and let's look at the decision tree. So the split occurs as physician fee freeze node. We can know the Democrats and Republicans percentage from the two leaf nodes. These are the two leaf nodes. Let's go back. Let's look at the output. We can have the variable summary. We can have the frequency count and levels of the input and target variables. We can know the predicted and decision variables as well. And this is the tree leaf report summary, and this is the classification table. The percentage of Democrats correctly predicted as Democrats is 97.43, and the percentage of Democrats incorrectly predicted as Republicans is 7.69. And the classification table for the validation data set is also shown. We can also have the false negative, true negative, false positive, and true positive rates of the class attribute for the trained data set and validation data set as well. Let's go back to our diagram. And next, for building the neural network model, I have dragged and dropped the impute node. Sometimes in our data set, we have missing values. The neural network model and linear regression model does not take care of these missing values. They simply ignore the observations. This results in the decrease of the training data percentage, and this might weaken the predictive power of models. So the impute node takes care of the missing values, and it replaces the missing values accordingly. So in the properties window, select tree surrogate for the default input method. And the next node is the transform variable node. This node takes care of the transformation of variables. Sometimes the input dataset might be informative if it is on some other scale compared to the scale on which it was initially collected. So the transform variables node takes care of the transformation of variables. Next is the neural network node. This helps in building the neural network model of our dataset. And finally, I have given the outputs of decision tree and neural network model to model comparison node. Let's look at the results of the model comparison node. This graph gives the cumulative lift of the decision tree and neural network model. Let's look at the output. We can know the misclassification rate. We can see that the neural network's misclassification rate is lower when compared to decision tree. And we can also have the true positive, true negative, false positive, and false negative rates of both the models. So in this video, we have looked at decision tree and neural networks model, and we have compared the outputs of both the models. Thank you for watching the video.